Welcome back at the Masters of the Code channel. After really longer break, I had just no time to upload new videos for some time, although I had some time to prepare stuff for my own. So now is the time to start uploading videos again and sharing interesting ideas. So if you hadn't subscribed my channel yet, now is the time. And also remember to hit the bell icon to get notified about my future videos. Today I will be talking about some container-like environments on Android. So environments which have separated namespaces. It's based on the Linux kernel namespaces feature, and also we'll use chroot. I had already uploaded video about it before, but it was completely different. It just used chroot functionality without separating environments. So now it's really better. You can run a few containers simultaneously, and also they are better separated from the base operating system and from each other. So let's start from the example here. I have already two containers pre-configured, and also I had it added using Termux widget to my Android home. So let's start from that. I will start the first container here and the second one, and I will use also Termux add new session, because I want one session to connect to the first container and the second one to connect to the second one. So I have scripts for connecting to the first one here, and I use simple script here which allows me to attach to the chroot environment to the container. And I will also do the same under the second session. I have to switch to the root. Okay, so I'm in. As you can see, you have different hostname. Also, I can show you that processes are separated. Also, whole mount namespace is separated, as you can see. And now I'm going to start VNC server. VNC server. So for the first container, I'm going to start it at display 0, as you can see, but I will also copy the whole command, so we can start it under the second container, but on the first display. So it will be available at port 5901 here and 900 for the first container. So now when I have it started, I can use bvnc3, for example, to connect to those environments. And for that I will define CM1 connection here first. I can use IP address or localhost in that case also, and test 1234 password for it. We will save it and also define the same connection for the second container, but with the different port number and the same password. I will also save it, and we can get back to those connections, and let's start the first connection. As you can see, we have the LXXDE environment, which is lightweight environment, although you can use any other environment like KDE or GNOME. And let's start something here, for example LibreOffice, because I just want to show you that you can run stuff and install additional stuff. And also we can switch to the so now you have OpenOffice started here, but we can also disconnect from that environment, connect to the second one. As you can see, it's separate environment. Here we can start, for example, Chromium. Okay, but it won't start because we are starting from root here, and we need to pass no sandbox option in that case. So for example, as you can see, no sandbox option. And now it can be started. But of course it's rather simple example here. It is meant to more complex stuff, because for that I would also I could also use, for example, Termux with proot without even needing root permissions on Android, but under Termux and proot I couldn't separate more containers from each other, because like any other app on Android, Termux is run in separated namespaces, but you can separate containers or root environments started from within it. So that is the main difference. And also I need really often stuff like stuff that needs root permissions. I have some complex OpenConnect, OpenVPN setup with split-brained DNS using DNS mask and also additional IP tables rules and IP root rules. So for that it's really great. And also I use caps service configured inside one of my container, so I'm able to use my printer that is not ready to be used natively with Android using caps without need to use some external third-party services here. Also I use SMBNetFS. I had also video about that in the past, but now it's a really different level because it is more secure. Okay, so now we can disconnect from those containers, and I can use VNC server with kill command, and I will do exactly the same under second container. As you can see, it's terminated. So now I can leave those containers, and also I have simple scripts to stop those containers. So for example, let's stop second container, and I can show you that I'm still able to connect to the first one, but the second one is stopped. So it works like expected. And we will also going to stop the first one. And now I'm going to show you how you can configure or prepare new containers. Whole scripts I use here, you can download, you have link for it below this video, and all of those scripts are of course automated. You need just customize some few options, but I know that it won't work on every Android device, so there is possibility you will have to change something also. So everything is located inside install _debian _ns, and inside we have install mine script, and also we have scripts in the bin subdirectory, and we have scripts install additions and delete additions. Okay, and we have in the main directory we have two simple config files, config.sh, which is base config file for preparing new container, and by container I mean here new image file. And for the additions we have additions _config.sh file. So that is the file which defines the installation variables. I will talk about it later. So now let's see config for the installation script which prepare the image file with Debian. We have really simple options here. First one is the path to the enter directory, and that path should remain common between different containers. It makes sense because you can only mount it once under OPT, so it should be shared between different containers. And also you just need to configure it once for your device. Also script requires BusyBox. Next you have root password. So it also will be used, for example, when you will start SSH daemon inside the container and want to connect. Also you have password for the Samba shares, hostname, Samba share external SD card share option. So when it's set to 1, Samba will share external card on your Android device also. You have next the size of the tree roots, the size of the image. So it's 6000 megabytes. You will also have that host name, as you can see, so we can easily know that it's correct container later when we will connect to it. And also we have path for the image here and the loop device number. We will change it to the different one. You can also do that if you have already used device for other containers. It should be something new. So you can create new container while using other containers simultaneously in that case. I will also make sure that I don't have it already created under micro SD cards, and I have it, so I will remove it also. And now I can start the whole installation script. You can also skip that part. I will speed it up a little, but if it's too long for you, you can skip it and go to the explanation part or to the next part when I will show you additional script for configuring additional stuff, like for example shortcuts for Termux widget. So after the first part, we have the image file ready. The image file is under storage microSD debian underscore cm64 and underscore prev1.image. So as you can see, it has a proper size. You could also map it to the loopback device and then mount it, and you would see that everything is in place inside that image file. And also you can even use it with only tree root, but we are not going to do that now because I want to use kernel namespaces properly. So I will use additional script which is located inside bin subdirectory install underscore additions, and for that script I have also a separate config file, and you can see it here. It's additions underscore config.sh. So here we have basic check that container postfix prefix had been passed, and next we have also location for the scripts using to manage that container, like starting, attaching, etc. And for me it's data local chroot underscore scripts, and here we have that prefix of the container with underscore chr postfix. So inside the directory we will have all needed scripts installed. Also we need to pass SD card target directory. It also can be located on your external card, so in that case it would need to be changed. I've already had that directories created because I've already installed 2 containers that I had already showed you, so I'm not going to change it. I also put here that option use external SD card. It's important because it it forces scripts to automatically mount SD card inside the containers. Here I have path to the external SD card. Also I have option for Termux automatic configuration. So in that case, I will show you it later also. It will copy shortcuts to the data.com.termux directory, and it will enable you to run those scripts easily from your Android home using Termux widget. And the last option is force_install_all. In that case, if you will put one here, it will force installing all steps, because that script checks if it already had been installed for a specific container, and it won't alter it if you would run it again. So by default it's set to 0. And of course we can also see this script briefly for installing additions, and that script works based on the main config and additions config files. So right now I'm going to just run it without any additional parameter. And one additional change I need to make, of course, is changing that postfix to pref1. So it will set that postfix for the newly prepared container, and after that I can just run the installation script, and as you can see it's done. Here I have all shortcuts and scripts pre-configured, also scripts for, at SD card, and other scripts needed for starting and managing chroot. So I can go to the Termux widget, refresh it, and after that we can see that we have those additional scripts here with the new container. I can use that, for example, start script to start the new container, and after that I can easily show you, after typing mount command, that we have it mounted. And also with opt bin ps command we can check that container also had been started. I can do that like that because it's the only one container started right now. It should be unshared. Now it's correct. So right now I can also use chroot scripts, and as you can see I have new subdirectory here, pref1_chr, which I'm going to use, and inside the directory I have also all helper scripts, but also I have mnt directory, and I have all the image previously prepared already mounted inside the directory. And of course I have scripts for mounting the opt directory in case it hadn't been already mounted, and also script for attaching and stopping the container, because I will also show it later, but maybe briefly. Inside that script you have customized paths, customized by installation script. So I have also the same script in other directories for other containers, as you can see, but those paths are different. You can even show the differences using diff command for that matter. And as you can see, some paths are different. So right now I can attach to that container, and as you can see it's the correct one container with correct hostname also. And like for others containers, we have just few processes, separate mount namespace. But one thing I want to tell you right now is I'm using just 3 separate namespaces. So first is the processes namespace, as you can see, the mount namespace, and the namespace responsible for setting separate hostname here. But I don't use separate network namespace. And also I'm not using here the separate users namespace. The reason why is because network namespace couldn't be used without changing kernel, without changing some binaries easily on Android, because Android has that additional functionality inside kernel. It's called paranoid networking, and it also means that even if you are a root user, you won't get working networking. And as you can see, my root user, and we should see rather group file, my root user needs to be member of those additional groups. So for Android you have those 3 groups, and also other users which needs network access on any level needs to be part of those groups. So without it I can't even ping or connect to any socket from inside the container. It's also correct for the chroot environment because it's the additional kernel feature, but because of that and some other changes on the Android, I can't use here some virtual network cards linked together between namespaces, and it won't work here. So I just skipped that functionality. And also another functionality is to be able to use separate users namespace, because the root user right now, the root user inside the container has the same UID as the user outside the container. So even if the functionality is limited here inside container, you have the same UID, and it's also connected with that paranoid networking feature of the kernel, which implies that user namespaces can be used here easily. So that is also the reason that it's not possible to port Docker or LXC on the Android right now easily without modifying kernel and without modifying init process and some other binaries. So it can be done, but it's not practical, because when you change something, it's unmaintainable, and you won't get also easy upgrades, easy patches, because in that approach you can easily patch your Android with vendor images, and it won't broke those features I use. And if I used user or network separate namespaces, it could break it. So that is the main reason. Okay, and right now I'm going to leave that container. I will show you that you can also stop it from the console using stop_chroot parameter. We can verify also using ps commands that it's no longer started, and also we can unmount and release the loop back device using unmount image. I can check for it. umount_img. Okay, so as you can see, the mnt directory had been unmounted, and also other mounts other than opt, of course, because we have entware there, so it's shared also for other containers. And what we can do also, we can check, for example, script for removing all those shortcuts, which I have also prepared, and that script is located inside bin directory, and it's called delete additions. And for that script we should pass parameter containing container prefix, and container prefix in that case is pref1. So what we should do in that case is just running that script with correct parameter. Of course we can run it without parameter, but you will get error message, or you can also pass not existing container. So again, you will get error message, and with correct container, you will see that it cleans those locations. And if I will run it again, it prints prefix not found, which is correct. And also we can verify it inside the directory chroot underscore scripts. As you can see, we don't have pref1 container anymore. Okay, so right now I'm going to also tell you something about those scripts, customizations of those scripts, and also about, really briefly, about pivot root functionality. If you will see start underscore dep script here, you can see that it uses something called pivot underscore root. And why I'm using that? If you are familiar with, for example, Docker also uses pivot root, and pivot root just allows you to switch root file system. So it will move current root file system to some directory, like for example old root subdirectory of the root file system, and will let you use some other file system as root file system. In that case, you have dot here, so it means it will use current directory as the root file system. And with combining it with chroot, it will allow you to switch that file system securely, because after that you can use umode with L, lazy option, so that after that command, the old chroot file system is not present anymore. So after using pivot root and unmounting with umode L, old root subdirectory, you are not even able to see that file system from inside that separate namespace, processes namespace. So from inside the container, anywhere. You can check prods, for example, prod subdirectory, but you are unable to get any subdirectory from the previous root. And without using pivot root, you are also able to do same thing, but not that nicely. And the pivot root is available on most of the devices, Android devices, from the Android 10, because Android 10 has the system partition based on the ext4 file system, and previously it had been based on the rootfs. And rootfs, unfortunately, has some implementation similar to tempfs. It hadn't let you to do same thing as pivot root. There was some really different technique used, because the same stuff is going on during init process of the operating system. It's also similar to the Linux boot process here. So pivot root is available to use with ext4 or other file systems which can be moved while them are still mounted. And for the rootfs, you are only able to use other technique, but it leaves old root file system still mounted, but you are only able to delete some files from that and mount new stuff. So from the security point of view, it's much less secure in that case. So as you can see, even in that script, I have the previous version, because first I've used it at Android Pie. So Android Pie at Galaxy S9 hadn't had that system image with ext4 file system, but whole different init process which used system directory from system image file as a part of the rootfs. And on the Android 10, as I said, the whole system image is the new root file system as a target to the init process. And you can read more about it on the Magisk website, because you have plenty of options here on different Android devices. I'm not going to cover it right now. Just wanted to give you some brief informations about that technique. Right now I'm going to start and tell you something more about those installation scripts. So the first and main script is used to configure, to prepare that image file, and all those scripts use that script _dir variable for getting the current path where the script is located. So it's the good technique under bash to use it like that. And also all scripts includes configuration, like you can see here. And next we have plenty of sections. So if you have issues with some sections, you should debug that particular section, and maybe even put exit 0 command somewhere after that section to be able to repeatedly debug the code. So what should be the outcome of each section? So as you can see, the first one is installation of Antware. So it's the environment that is required for the next steps, because when you have Antware, you can install the Bootstrap package. When you have the Bootstrap package, you can prepare easily first stage for the Debian image file or any Debian-like distribution. So if you would like, you could have Ubuntu here, for example. So that first section is responsible for installing Antware in case it hadn't been installed yet. So as you can see, the proper directory is checked, and after bind mounting that directory, we are checking that we have already opkg binary installed inside opt bin directory, and in case it's there, it's not there, we are installing Antware, and if it's there, we are just skipping the whole installation. Next, we are preparing Debian image using the Bootstrap package. So the first step for that section is to prepare the whole device. So we are just creating file filled with zeros with correct size, stated as I had previously showed you in the configuration file. It's in config.sh here, and then we are creating new loopback device. Next, we are mapping that device, that image, to that correct device. We are creating new ext2 file system. In that case, you can also change it for the ext4 if you like. So you have also journaling here enabled. Then we are preparing directories, mounting that newly created file system, and then we are ready to start the bootstrap process, as you can see here. Also, if you don't want or you need to use different architecture, you can easily change it here. So you can use ARM HF instead of ARM64, for example. But you also will need to supply some binaries, some additional null binaries in correct architecture later, because not every stuff is provided by the Antware here. So I had to provide some additional precompiled binaries here. So you need to remember about it, and if you want to change it, you will also need to provide those binaries also, because they won't work in case you have it in wrong architecture. Also, after the bootstrap process is finished, we are preparing some initial configuration script. The script that we are going to run after the bootstrap is ready, but also inside separated namespaces. So it's more secure, and it's also not going to harm your base operating system mounts or other stuff. So it's in that case it's more secure than the only chroot approach. So inside the script you can see we are starting second the bootstrap stage also. So after that we have the whole system fully configured, and we are ready to inject some additional stuff. Like I mentioned, even root user needs to be member of those additional groups to be able to use networking, for example. We are also need to configure some additional apt repositories because, for example, some packages like socat needs to be installed from the previous stable Debian version, and I will tell you a little bit more about it later. And after that step, we are also adding apt user to the correct group, so we are able to install new packages. And we have also some other helper script. We are installing some predefined packages here. Also you can change that list, because you, for example, maybe you don't want graphical environment like XDE, but some packages are needed also by helper scripts. So expect package, for example, is needed, but also we have next the socat package also needed, but from the stable distribution. So that is important. You can also skip some other packages like Samba or others if you don't want those packages to be installed. Next we are configuring locals, setting root password, setting Samba shares password, setting host name. We are also pre-configured Samba here, and at the end, okay. And why we are using that nested init helper script? The reason is we want to start that script using su hyphen and the command, because that will cause that we are initializing the user environment. So without that we would have some default paths, some default variables inside user environment set to those from the Android. So for example, you would have wrong root directory home variable set, and also we couldn't use those group settings. Like I said, that even root user needs to be part of those additional groups. You can see it here. So those groups wouldn't apply without doing that. So that is why we have two levels of scripts, and that is the second level. That's why those actions like installing packages and some other stuff is located in those nested script. And at the end, we are also switching profile of the users, and also we are removing that those the bootstrap directory and those helper scripts. So we just don't need them anymore. And after those scripts, after preparing those scripts, we are setting proper permissions also, and also we need to copy some additional scripts, some additional settings. I will also show you it later. And we are also preparing some subdirectories. For example, that shared directory is for sharing stuff between container and the base operating system, because it's in the same mounting namespace, and other stuff are of course located in separate mounting namespaces. We also need to supply script that will set host name, and of course configure resolve.conf file, because without it you are not able to make any DNS queries from inside container. You can of course change that default Google DNS for any DNS you like here. And we are also configuring VNC and other stuff. If you don't want use it later, you can delete it from here. And after everything is ready, we start the whole second installation stage using unshare binary. And unshare is the standard binary, really simple, and that binary allows us to just start something in the separate namespace. So as parameter, you put something like fork, something like separate process namespace, and stating that you also want to mount the new prods file system under the container, and also that you want to expose all mounts from the operating system with unchanged settings. So we have it here because I modified with my custom scripts, and without that option, and it's especially important when you want to start the container later. It's important because without that option you are unable to use that shared directory, for example. And of course, after that, as parameter, we have just bash and script, the basic script. To do that stuff I've showed you before. You have it up here. So those scripts. And after the whole configuration, we are ready to unmount the directory which keeps the image. And also we can unmap the loopback device. And after that, this is exactly the point when we have the complete image file prepared. And when you want to change something, how container works, or how you can attach or interact with the containers, you should see those scripts responsible for managing it, and those stuff you have it located inside the bin directory, and also inside the Debian resources directory. So Debian resources contains all helper scripts and settings that are needed by the chroot environment, and those scripts in bin directory are responsible for example, mounting Antwer in case it hadn't been already mounted. The Antwer.sh script is responsible for installing Antwer in that case. So it's the default installation script from the Antwer side. But mount Antwer is responsible for mounting the Antwer in case it hadn't been already mounted. So you can run it as more times as you like. It won't harm anything. And you have also the main script start_dep.sh, and that script is the core script responsible for interacting with the containers. So that script this script have separate sections, and it has all shared options gathered in each case block. So either some default variable settings or some other actions. So for testing purpose, for example, you can also change some of those variables manually. Of course, that generic script has some options set to default, because that, for example, number of the loop device is altered during that additional installation script part. I will also show you it later. But in that script, for example, you can see how attaching to the chroot and other stuff works. For example, for any of those three actions, we need to get PID of the main process inside the container, and the main process is dump init. Dump init is the really minimal init process which you can run inside the container, but it is crucial to run some init process because it can handle all of child processes signals correctly. So for example, killing and other stuff of the child processes correctly. And you could of course use, for example, bash as your init process, but in that case you won't be able to handle those signals properly. So dump init is the package available under Debian, which is also being installed during the installation process. You can also see the mount image section here, so it is rather easy part. Unmounting also, and you can see the start chroot part here. We are using again unshare binary here, which is supplied by Entware. In that case, I use here some precompiled binary. You can also switch switch it to the Entware version, and we are starting the init chroot, the base script. So the base script is the current script. It's start underscore deb.sh with the parameter init chroot, and you can probably notice that we don't have any shell defined at the beginning of the script, and that is because the same script is used under base Android OS and inside the chroot, so it wouldn't even work like that. So that is the reason, and we are starting the chroot with start chroot option after the mounting part, and it just runs the same script with init chroot option. You can see it below inside separated namespaces, and in init chroot section you have that mounting part. So with the exception of shared directory, we are making all mounts we've got from the base operating system namespace as slave ones. So it means even if we would unmount something under that new namespace, it wouldn't harm the base operating system at all. And without doing that, it could harm, or it could, for example, unmount some directory also on the base operating system, and we don't want it, of course. Next, we have also mounting of devpts and also prots directory. We have the pivot root stuff here, and at the end we have the execution of the chroot on the current directory, and we use something like capabilities. It's the feature of the Linux which limits even the root user permissions. So we don't want some additional permissions. We don't want, for example, to give root user possibility to use chroot from inside the container, because it's the part where somebody could or some process could easily break the container restrictions, and we don't want to give that, because it's also not needed inside the container. If you want that functionality, you can also remove that option from here. And also we don't want the possibility of setting the whole system time, for example, from inside the container, or TTY configuration, or even making new nodes under the dev directory, because also somebody could just make some new device like SDA or something like that, and get access to the devices from the base operating system. So instead, I use pre-made nodes under dev directory, and if I need some additional ones, I just use the mkey node command, so I'm able to add new nodes. Here we are also cleaning a directory with sockets, because we have that additional directory here with sockets from socket, and it needs to be cleaned, because with every attaching or running command inside the change root, we need new socket. So it could just fill up the whole directory, or we could even have thousands or even more unneeded files after using it for a while. We are also starting the hostname script to set the hostname of the container, and we are switching to dump init process. And as you can see, we are using exec option. It's the option in the bash that allows us that dump init process or any other process will switch with the current one process. So how can I easily tell you that if you would use PS for listing processes, for example, without exec command, you would see some stuff like chroot, capsh, and other child processes. And when you are using exec, the dump init will take place of that most top process. So and even earlier, the chroot will take place of the, for example, bash process. So when you use PS to these processes, you will only see that most top binary like unshared, and after that just the dump init binary, without all those other stuff between. And it's also the only good way to start init process inside the container. And next, we have that part responsible for attaching to the running container, and for that we are using other binary nsenter, and that is the binary that is not yet supplied by Antware. So I had to use precompiled one. Also, in case of the unshared binary, I've also used precompiled one with more options that one from the Antware supplies. So that is why I've also added unshare and not just nsenter here. And we have some few basic options, and we are entering the container. And it's not enough to just use it to connect to already running process, but we also need to use chroot again and limit capabilities again, because after just running nsenter, we just enter new namespaces, but nothing more. And by the way, it can also be used to tap to the Docker containers and other stuff that nsenter binary. It's the standard Linux tool, by the way. We are using some additional helper script socket underscore attach, and also we will see it later. And those other commands are really similar, but it differs a little. Run cmd change root, it just lets you run some commands and leave the chroot. So you are not attaching interactively. It's good, for example, for using inside scripts. So you are able to just run something. And here you can see that all parameters commands are passed as base 64. So without base 64 here, it's the easiest way to pass it in the exact same form like you need. In any other case, some spaces or some other signs could be misinterpreted during that execution. And at the end you have stop chroot option, and also you have that option chroot ready. It just lets you check that container had been already started. It's a good option to use inside scripts. So first you are checking that container is started, and then you are running some stuff. So if it's not started, you can skip running those additional stuff. And now I'm going to tell you something more about those additional resources, because you have, so I will maybe use ls command, and you have some pre-configured nodes here. That is directory which is being copied by the installation script to the inside of the image file system. And as you can see, you have some really basic nodes, but you have, for example, views used by SMBNetFS, for example, or other mount commands inside user namespace. And also you have tune device, for example, suitable to use with the VPN binaries. And also we have the hostname script, really simple script. I won't cover it right now. And we have also that install bin install not bin Debian resources install the bootstrap second stage. And as you can see, we have really simple script here. So when we first installing, not using start dep script to start or attach to container yet, but just installing, we also make those additional modes as slaves, and we are also preparing some other basic stuff and use pivot root to have minimal container environment prepared. What else we have here? We have, for example, profile.d, and we have here locals also pre-configured. So locals are being loaded during switching to the using, so entering the user environment here. And other scripts for example, handling history under the bash. So we have ignore space here, a nice feature that lets you skip some command from the history when you prepend it with the space. It is also used in additional scripts with socat, so it needs to be here. And the third one is the standard script from the Debian. It will pre-configure some other stuff like proper propt, for example. And for the other stuff, we have screen also pre-configured, that you will have some nice tabs, colored ones, in the lower part of your screen. So it's the file, it's additional file. You don't need it. If you don't want to, you can remove it from here even. And we can some VNC stuff like X startup. It's also some default stuff, but it's needed if you like to use VNC server inside those containers. And we also have free socat helper scripts and socat attach. As you can see, we'll do some basic stuff, and maybe I will briefly tell you about the concept with socat. And the whole concept is you can't run something under the container using nsenter command under that init process. So I would be able to run something without using that socat stuff, but it's the same flow like, for example, even Docker has, because if you will connect to the Docker container with docker exec command interactively, maybe with TI option, for example, and you will put bin bash or something, and you will check processes with ps command, you will see that you are attached not to the init from the container, but you are attached to the base operating system init process, and that is for me some security risk, and also it's not working like I would expect. So I used SOCAT to pass that limitation. And SOCAT, you can think about SOCAT like maybe you know netcat, or even maybe like telnet, because it's simple binary which lets you start server part and then listen, or for example network port or socket. In that case we are using socket inside the container because it's the most secure way. You don't have you can't attach from outside of your device to it, outside of the container also. And also you need root permissions to attach to it, which is really also important. So not just any user or any process can attach to it, but you need proper permissions. But to pass to beat some limitations, we need to get terminal size here to configure things properly. And also there are limitations in functionality in next SOCAT versions next to the Debian Buster distribution. So that is why we are installing that particular version from the Debian Buster branch and not from the next ones. So it's important. So after getting the current terminal size, the current console size, we are also preparing variable for the socket. It should be something that hadn't been already used. So I'm using date with timestamp format here, and I also printing those variables on the console that we are ready to start the SOCAT server part. And as you can see, for each console we have separate server process here, because we want also separate terminal, fully separated. So we are not able to use the shared SOCAT process here. We need to put some common options here. You can also maybe check other options if you like. But those options had been tested by me. I use it on the daily basis, so they work good for me. And we are starting in the background, of course, as you can see here, and which is really interesting also. If you don't know it, we are using something as double forking here, because you have uppers and the end of that command, but we are also have those parentheses, right? And what it means, double forking means that we are attaching some process in the background directly to the init process. So in that case we are attaching to the dump init previously started, and we want just that. And that technique is also used by daemons or some services on the, for example, Linux. And if those services, that stuff is written in bash, that is the way to attach to the init process directly in the background. So that is why I use it here. Then we are waiting for the socket to be ready, as you can see with upper S option. And at the end we are using just some additional expect script. We will move to it right after ending that part, and we are passing terminal size and the socket. And after that we are killing the socket server parts also to clean stuff. And we can now move to that expect part. And in that expect part we have the expect code. So we are use set command to set the variable, both variables, to the options passed from the previous script, and we are spawning socket client here. So with different options, we are connecting to previously prepared socket, and we are expecting some prompt on the system. So that is why I've pre-configured that etc profile.d directory scripts which are there, that I'm sure that we have the same prompt. That is also important. And at the end, we are sending stuff to the terminal, and we are using spaces, and you can see here, because I don't want that stuff to be put in the bash history. And that is also why I pre-configured profile before. And next we have interact, so we can interactively do stuff on the console. And after that, like I said, we have kill on the socket server. And the last script, we have script for running command not interactively from scripts. And as you can see, it differs a little. We have first, we get parameters and converting it from the base 64. And then we are doing stuff similarly. So we are starting socket, waiting for socket and running command, cleaning after command. So we are killing the socket server. So I think we have everything here covered, and also we can see right now we can also see stuff like the last part. I think the script for configuring those shortcuts, and also script responsible for installation of that new container. It's located inside bin subdirectory install underscore additions. We can see install additions script, which is responsible for, like I said, configuring all shortcuts, and scripts responsible for starting, attaching, and using the specific pre-configured earlier container. First, we can see that we are including configuration. We are removing temporary directory here. We are also copying templates files. We have those template files located here inside data directory. So we have some pre-configured scripts, as you can see, but those scripts lack proper paths. For example, you can see that we have script here, but that path is not the correct path for the current container. Also, we have here scripts which we want to copy to the SD card, but also without proper paths to the specific container, like you can see. And we will fix that, because the first part will copy those scripts to the temporary directory, and we are then using set command to replace all crucial configuration parts, variables inside those scripts, and we are replacing with the currently configured container postfix. So in the last example, when I wanted to have pref1 container configured, it had been replaced with that specific name. So next, the variable is checked, use external SD card. When we want to use external SD card, we also add some helper script. It is script for Magisk. It's being started just after Android is booted, or to be more precisely, during boot process, and it will link that storage serial number of the SD card to the name we want. So we want always to have storage microSD subdirectory pointing to microSD. So even if you move cards, if you copy some files from one card to another, you are able to use the same standard path, so you don't need to change everything. It's really convenient way. Also, next we have some other configuration options to be changed here for the start _dep script. So the main script used to interact with container, to mount, start, and as I already showed you, attach or run scripts under container. And then we are checking in each part, for example, if we've already prepared the directory under SD card. In case it hadn't been prepared, we are copying scripts processed by set. The same if we don't have the proper data mount location, we are preparing it. Also, if we don't have those helper scripts responsible for interacting with the container, we are also copying it in that case to data local chroot scripts subdirectory. And of course we have the container name, the directory with container name, and we are putting those scripts inside that specific directory. And also we have part responsible for deploying that script responsible for mapping external SD cards directory under storage. And we have the whole Termux configuration part, which basically copy shortcuts for Termux and changes proper user and group for the Termux application here, and also restores SE Linux context, which is also important and wouldn't work other way with SE Linux enabled, which is true for almost any Android version currently. So it's important. And as the last part, we have something like directory for SMBNetFS. So we are also preparing that. If you need separate directory for your containers, for example, you can change it here. So you will have separate directories, and if you don't need it, you can leave it like that. So it won't be processed, because it will work only once when you install first container, and then it will just skip it. And of course we have cleanup of temporary directory at the end. It was quite long video, a lot of stuff. I hope you enjoyed it. See ya in the next one.